Hello and welcome to another video. Today we have from a viewer a B450M mortar from MSI on our bench. I do not know what is wrong with it, so we are going to be starting with our initial checks on resistance. So let's go first for one of the most important, which is the 12-volt CPU, that we have high resistance, and then from the 12 volts of the CPU to the face that we have high resistance, so that the 12 volt isn't shorted into our processor via a MOSFET. Then let's connect the ground via USB here, and let's now check bottom left pin, 3.3 volts, high resistance, 12 volts, second pin from the top left, high resistance, 5 volts directly to the right from that, also high resistance, 5 VSB, fourth pin from the top left, high resistance. Looks good, which means we can build this board up. I think I can see residues of flux. Was there some work done here? Not too sure if someone has worked on this board before, but we will now plug a CPU into this and see if our passive rails come alive with having a CPU in here. And we're going to see how much power consumption we have in standby mode. So let's see, let's apply power. And oh, it's high. It's very high. Have a look at that. 400 milliamps. That is way too hot. There is something wrong here. When you have that, I always go over to using my lab bench power supply for the 5 VSB, because you can damage these adapters. These adapters have very low voltage current capabilities on the 5 VSB. So what I always do then is I take my bench power supply and then I connect the 5 VSB via that in order to see. So let's get a ground hooked up. So ground is hooked up. Let me get, I always take tweezers to inject the 5 VSB. So fourth pin from the top, which is 1 amp of power consumption, which is a lot. Let's remove the battery. Yeah, and the power consumption is rising. Let's get the thermal camera out, because I want to know what is getting so hot in standby already, because 1 amp of power consumption on a board that has no LEDs is definitely not right. So, thermal camera, and we instantly see bottom left something getting hot. We have a little bit of power going into the Ethernet, but this is getting way hotter. So I think this is a regulator, linear one, and I think it's the 3 volt regulator, the 3 VSB one, that is getting supplied, and it might be either shorted by itself or its output is shorted. So let's go under the microscope and check for that. So we can see there was definitely work being done here. Now the question is, yeah, someone replaced this chip, or someone tried to replace this chip. Question is if it is on the right way or not, and if our output is shorted. The output, I have experience with this chip, so I do know where the output of this chip is. So when connecting a ground, the output of this chip is this pin right here, Let's see. But the output seems to have good resistance. This is its input as far as I know. Also high resistance. Yeah. So is it the chip itself? And is it maybe on the wrong way? For that I will need a reference. But there's no reference printed on the board anywhere for pin 1. So let's go into a board view then. The MSI board views are really easy to find for the most part. Let's see. We will need this right here. MS7B89. This is our model number, and this is the version 1.1 that we have here. So let's search for that quickly on the PC. So this is the chip in question, and indeed pin 1 is at the bottom. We have the enable at 2. We have 5 volt dual coming at number 3. We have 4 volts 3 VSB control, and then we have the 3 VSB as an output right there, and then there's the 3 VSB feedback. Okay, question now is, we didn't see a short circuit on 3 VSB, and we didn't also see a short on 5 volt dual. So why is this getting hot then? Let's turn it on once, or let's put the 5 VSB into this pin, or just inject the 5 VSB into the 24 pin, and then look for the voltages that we have on that pin and on that pin if they are right. And if this one maybe is lower, the 3 VSB, than it should actually be, we might still have a problem with 3 VSB, even though we don't really see a low resistance there. So let's try that. So I have 5 volts connected to the 5 VSB. Let's now see what we have on our pins here. So here we need 5 volt dual, and 5 volt dual seems low already. Okay, let's see. Do we have 3 volts here? We do have 3.3 volts. So I expect our 5 volt dual might actually be our problem here, and not our 3 VSB. Even though but that's weird. Why is that controller getting hot then? I will have to inject voltage in each of the rails to see what's the power draw of the 5 volt dual. It's basically the same, and the chip is the one getting hot. Let's inject 3.3 volts. If we inject 3.3 volts and the chip is still getting hot, it's just the chip that is dead. So the 3.3 volts gets also an amp of power draw. And is the chip getting hot? That's the question. Let's go into the overview for that. So let's have a good look. I now have 3.3 volts on our on our power supply. Question is now, is it really just the chip itself? Because the chip definitely does get hot, but I feel like there should be something else. And it might be our PCH. Oh, this might be that chipset then. Rarely to see that on AM4, but let's see if that is actually the case. I think I found the problem. So let me have a good look. So the PCH doesn't seem to be the problem, or the chipset in this case. But there's something very close to it. Is that a capacitor? That seems to be a capacitor close to the PCH. I cannot believe that, really. Let's zoom down a little bit. So, to see in what area we are. It's right to the left here. Yeah, right there. Is that? Oh no, that's a linear regulator that is getting hot. And that linear regulator might be for then the PCH. I get it. Because it's very unlikely to be the regulator itself that is shorted. It can be, but it's probably not. So, to show you that linear regulator, let's go under the microscope. Which is... And this is our linear regulator at question. And the bottom right pin is its output. So, and that feeds into the PCH most likely. So let's see for the resistance of this pin right here. But this pin does not seem to be shorted. That's not what I would expect. Let's clean this up just a little bit. And let's go also then into the board view to investigate what this is for, because I'm pretty sure this is for the PCH itself. Yeah, so let's go over to the board view. So it doesn't seem to be this regulator. The 5 volt dual was kind of low, but it seems to be going into this regulator and then going into feeding this regulator, which takes 3 VSB, has ground, and then does 105 volts at the output right here. This goes. This is a 1K resistor. This is for the feedbacking. This is for feedback also, and it goes into this coil right here. And the other side of this coil then goes into the PCH. Yup. This might be a dead PCH then. So what we might need to do, let me think. Because what we can do, we can isolate this thing. So what we do, we take this thing out, and then we see once again for the power consumption. If the power consumption then is lower, we can then put in 105 volts, this probably should be, into here, and see how the board then behaves. So let's see for that. Let's remove this thing first, and then see for the passive power consumption. So let's get some flux onto here. And right there, we take some leaded solder, and we get some leaded solder to all of our pins here. So all pins have leaded solder, and what we do now is we're going to be taking our hot air, and let's remove that component, that regulator. And the regulator is out. Keep the regulator, because the regulator isn't broken. So the regulator is important here for us. But let's clean up the area a little bit. So more cotton buds. And getting rid of the still hot flux that we have here. Let's get rid of that short circuit that we created here. Just like that. Now the regulator is out. We should still see no short circuit on the output there that we have. So this is the output as we saw. We still do not see a short. It's 350 ohms, which is really high. But let's go in the overview again and supply power to this board and then see if we have any change. So we would expect now way lower power consumption from this board. So there we are, 105 milliamps. But I don't think the board would start up now. It might have a reaction to the power button, but I don't think it starts because the PCH isn't getting its voltage that it needs. So let's get a postcard into here just to see if there's any reaction now. So let's see now. It actually starts up, but it gets stuck at the CPU LED. Yep. Because it cannot initialize the CPU, because V-Core is probably not running because the PCH isn't running. Okay, so let's turn this off again. And what we're going to do now, we are going to be supplying the 105 volts by ourselves. So let's connect my probes to the power supply and adjust it so we have a precise measurement. There you can see. And let's now get as close as we can to 105 volts. Because the resolution of the potentiometer to do this is very, very high. Very low resolution. So it's hard to properly adjust this. So that should be fine. 106. That's what we're going to be using. Because we're going to have a little bit of a voltage drop as soon as we draw current from it. So we're going to connect that, and we are going to be connecting the other lead to that output pin, and we only have 50 milliamps of power consumption. Okay, and now you can see higher power consumption also from the board. So I will do this again, and let's now try to start the board. So we now have a CPU LED, 1.5 amps, and let's see if we go any further. But the PCH gets quite warm, the chipset. We have CPU and nothing. No initialization anymore. Not getting any further. Very interesting case here. Okay, let's check for the resistance of the, not the resistance, but if the voltage of the 5 VSB now has, of the 5 volts dual, if it's now properly where it should be, or if we still have low voltage on there, like we had before. And I want to see if the chip still gets hot here. So let's see, the 5 volt dual. Now the 5 volt dual is good. And the 3 VSB is also where it should be. So I would guess that this is actually dead PCH, to be honest. Let's see now, do I have a reaction? Yeah, we do have a reaction to the power button. Let's see on these other coils that we have. 105 volts right there. This should be, there's incoming 12 volts. And I think there should be 2.5 volts somewhere as an input. 3.3 volts, so that is fine. Also 3.3. So it's kind of hard to tell what is happening. If there might be... Currently the biggest problem is there any more damage on the board that we do not know of? Or is it actually just the dead PCH? That's kind of hard to tell. Because the BIOS might have been overwritten and been overwritten badly, and we do not know that. Putting in RAM shouldn't really matter. It shouldn't change anything from a CPU LED, but just to be sure. So, let's see. Putting in once more the 105 volts. Yeah, the board is getting nowhere. 1.6 amps. Let's see for some other voltages, just in case, if we're missing also something else. Because currently I'm not too sure. I think AM4 is supposed to be getting at least to some point of booting up, even when you don't have a PCH on there, I think. But I'm not too sure. So I want to look if there's any other faults. RAM voltages are all there, okay, so that might not be the problem. I want to flash this BIOS just to be sure that there's a proper BIOS on here. And I want to look for some physical damage, but so far it really looks like we just have a dead PCH on our hands here. So let me quickly flash the BIOS. There's a there's a SPI header right there next to the BIOS chip, and I will just be connecting to that in order to flash it quickly. This shouldn't take too long. So I'm not going to show this process because I don't think it will lead anywhere, but let me quickly do it just to be sure. So I didn't want to show you the BIOS, but pretty sure this is the BIOS. I think there's a blank chip on here. I've never seen that before. Have a look at this. We are reading the chip out. I'm pretty sure I've done this correctly, and the chip seems to be empty. What? That is something I've never, ever seen before. Look at this. This chip is empty. How is this supposed to boot? Why is this chip empty? Well then. Someone has been setting me up. Let's flash a BIOS onto here. This is how it's supposed to look like. There's data here. Well then. Very interesting. I get a verification error on this chip. Verification error at address 0x00, which means the first pin of that chip. So if we're reading the buffer again right now, we should still have a blank chip. So question is there a problem on the board with the connection? Or is the chip actually dead, the BIOS chip? That would be very interesting to know here. So yeah, the chip is read out and it's empty. And trying to flash a file onto here. It erases instantly, it programs, but as soon as we go into verification, it actually fails. That is interesting. We will have to look into the area if I can see anything there, that there's a missing resistor or something similar to that. And if that does not happen, we will have to take off the BIOS chip try to flash it out of circuit, and if that still gives the same result, the BIOS chip is actually dead. But it's weird because it's responding to like reading and similar stuff. Yep, and verification failed. Okay. I will have to. Let's go under the microscope and have a look at that. So the area looks fine around here. I'm not too sure if this. There's definitely been probing around the chip. This might have been killed because you know what this looks like? This either looks like pogo pins being stabbed into this chip. Like if you can see, it looks like there's pogo pins there and there and there connected, and someone tried this. Or there was a clamp tried to be attached to this. So what I want to try is I would want to resolder, or let's just unsolder it instantly because it might be faulty. So let's desolder this chip. So same procedure as always. We are going to be applying leaded solder to all of the pads here. So a little bit of Captain tape to prevent damage to that pin header. So not a good application of Captain tape, but it will suffice. We're just going to be quickly taking this chip off and putting it onto a breakout board. So still an error while the chip is on a breakout board. So I will have to get a different BIOS chip for here. So let me get into my stash and get an actual BIOS chip for here, and then we will be able to flash it. Very weird, the BIOS chip didn't look like anyone has touched it before. And it does read fine, and you can get into the identification of it, but no content, not being able to write to it. Very weird behavior, haven't seen this one before, but let's get a different chip, flash the BIOS onto it, get it onto the board, and then proceed from there. So I've taken a new chip and instantly put the new chip onto there. It is exactly the one that was on here, and as you can see, the connector is still fine. The soldering area doesn't look the greatest, but we can clean up the solder by just getting some leaded solder into here. Just getting the pins nice and shiny, all here connected. Little bit more flux would help here, but it should be enough. Right there. So the chip is definitely on properly now and has the right orientation. Now this chip is also empty, and I wanted to do it this way to flash it to see that the connections on the board are properly. So if now everything works fine, we should be able to read the chip and also flash it. So that also tests some of the resistors on the board, that they are not the problem here. So cleaning it up already, while the flux is still hot that we had here. I did melt the sticker a little bit. I didn't even realize that the sticker is right below it, but it doesn't really matter. It just looks a bit ugly. So chip is in place. This is just a new one that I had because I bought stocks of basically every single BIOS chip, because BIOS chips just die. They can just randomly die, just like in this case. So that's why I have them in stock. You could also just take this from a donor board and then just flash a different BIOS onto here. That is no problem. You could even take a Windbond chip or a Giga device chip and put it on here, as long as it's a 1.8 volt chip and has the right memory size. In this case, it's the 128. D70 is with the 73F. You see that it's a 1.8 volt chip, and the 128 is the size on the EEPROM itself. So let me get onto the PC and flash this, flash the right firmware onto here. Very interesting. I have the new chip on here and I get a verification error trying to flash this chip. Let's what you can do, you can increase the voltage a little bit to like 2 volts, for example, and then try that. That sometimes needs to be done in order to write the buffer to memory. So let's try that. And still a verification error. Okay, this is weird. Well, so much for me already soldering it on and trying like that. So let me desolder it, getting it onto a breakout board, and then try again. So I do not know how that happened, but that MXIC that I just put on here was also not able to be flashed. I got the exact same error. And I tried a different programmer. I tried my CH programmer, the old one that I use, and I still got an error. So I was able to do the same thing, reading it and then trying to program it, and it failed at the verification step. And now I've proceeded to just take a Windbond IC, and everything worked just fine for the first time. Like right from the get-go. I was able to flash the chip and read it out and everything. And yeah, now we're going for the Windbond IC. I do not know if there's something wrong with my flasher with this special IC, or if I just had a dead one. And I put the chip on the wrong way, didn't I? Man, I did not pay attention because I was talking. Yeah, so I do not know how that happens, that I had, because those chips were brand new that I have, and I have used them in the past, and the ones that I've used definitely have worked. So it's weird. So don't know how that can happen, to be honest. Because the weird thing is, the IC respawns in order when you try to talk to it. And not only that, but you can read and try to write to it. And yeah, from like completely dead chips, I wouldn't expect behavior like that. So I really cannot tell you what was happening with those. And if we now are going to have an actual something more when we're trying to boot, it's actually the BIOS that was broken, and I just randomly had also a dead chip. So I'm really interested now what will happen. So let's clean the area off. I just used so much hot air so many times here now, because I had to put on chips and off just back and forth, because I got so confused with this. Because the last thing you saw was me putting on an MXIC, a new one, and I did not mix them up. That was definitely a new one that I took out of the package. And yeah, I was just like, yeah, I'm just going to flash this quickly via the SPI header that is right here, and everything is going to be fine. But yeah, it just didn't work, and then I went back and forth with different programmers, and then I desoldered the chip, trying to do it on a breakout board instead of the flashing on the board, and all of that just did not want to work. Gave me the same error. Yeah, and now I went for an for a Windbond chip. I have less problems with the Windbond chips all the time, so if you want to get chips, get Windbond chips, because I have better experience with them, at least for this kind of chip with this capacity and the 1.8 volts. So yeah, now the chip is on here. And now I will, this chip is already flashed. I started with putting the software, and just to be sure that the chip wants to be programmed. And yeah, so now we can get back to the original issue that we had with the PCH and try this board out. So let's see if we now get something. We have 100 milliamp. Oh, the connection isn't there. Hold up a quick second. So now we can see the 105 milliamps. Let's now try to press the power button. I'm not going to be injecting the voltage for now. Let's just see if we have anything past a CPU LED without that. And if we do not get anything, we are going to be inputting the voltage. and then try to get something. So let's see now. 2200G in here. We get CPU LED, 1.4 amps. Okay, so we still have no change. Let's then now try again with injecting voltage into here. So let's see. We are going to be injecting 105 volts. And let's now hit the power button and see. Do we get any change? No. Seems to be the same. Very interesting. So still same behavior. I want once to put on that regulator back again that we took off before, and I want to see if the board changes in behavior. I wouldn't expect so, but I just want to see how basically the original state was, even though it could blow up my adapter, but I just want to be sure and want to know how this behaves when that is also on there. So let's see now. This should now be too high power consumption, but I just want to see for a second if it behaves differently. But no, it doesn't. It just, everything is just getting hot. Okay. So I think this might either be a dead PCH or there's still something else missing. The video is getting quite long. Let me make a break and let me see if there's knocked off components. And if not, I would guess that this is a dead PCH. So after a lot of time, I think it's time to call it on this one. As a last resort, I want to show you the area. Right now, the PCH really doesn't get hot, or the chipset. And let's see, injecting. So trying to look at the PCH while injecting voltage, but it really doesn't get too hot. I think it only really happens when you have all of the voltages running. So trying to power up the board. I don't really get, it's kind of hard to tell how this board is not working right now. Like why the regulator for it actually gets so hot while still everything here is not that hot. So you can very clearly see that there is temperature in this PCH right here. Just you cannot see it well from the top because of the very reflective heatsink that it has. But I cannot leave my finger on there for long. And yeah, from the side it's easier to see that this is pretty much a dead PCH on an B450 chipset, which I have very rarely seen. So this one is one for the pile. Just talking money-wise, it's just not worth replacing the PCH on here, or the chipset. But as for a challenge, this might be an interesting one. I will definitely put this to the side. This belongs to a viewer, sadly. So he has a dead PCH on this one. But if he lets me keep it, I might at some point try to put a different chipset on there. Because I definitely do have good chipsets on donor boards for this. But money-wise, it's really not worth it. This board really threw me for a loop. This will be quite a messy video. But what we have... So the previous one that worked on this board definitely knew there was something wrong with the 3.3 volts. He tried to solder there, but what he didn't see is that the problem was further down the line. So you had a voltage regulator that took the 5 VSB, converted it to 3.3 VSB, and that got overloaded because the regulator, the 105 volts for the PCH got overloaded. And that one is the actual one that got hot. The output resistance is really high, so it's weird that it is getting so hot, but you were able to see that I couldn't touch the PCH because it was getting too hot, and especially that linear regulator was getting too hot. Okay, my camera just died, but we're going to continue without the camera because you can see me. And yeah, And then we had all of the shenanigans in between with the BIOS, which was very weird, and I cannot really tell what happened there with those two dead MXIC chips. But yeah, that also can happen, I guess. But yeah, I would call this to be a dead PCH, and this needs a different chipset on here. So I hope you still learned something. I hope you enjoyed the video. Thank you very much for watching. All of my tools are linked in the video description as always. This was Mainboard Medic. Thank you very much and goodbye.